methodika sa sampling technique. Okay? So, thing to consider, kaya ako nilagay food safety kasi alam natin sa food safety, mostly ang sample dyan ay dirty matrix. And you know that matrix is always a bad news in any sample preparation. Okay? Sabi nga nila, matrix interference is a sample analysis is a nightmare. So, kumbaga, may kasabihan yung mga food safety analyst sa laboratory. Kung yung sampling daw is yung tinatawag nilang ghost at the door of the laboratory and yung multo sa pintuan ng laboratory, ang sample preparation actually is the actual na multo sa loob ng laboratory because it's really a nightmare. That's why, but before we proceed, let's look at ano ba yung goal ng sample prep. So essentially, talagang the very main goal is to remove the interference. As much as possible, you have heard me probably making a presentation for HPLC and GC in the past. I always mention particularly for GC. GC is a clean GC. Dapat may sample prep. Remove all interferences. Kasi ang interferences, ito yung nagko-contribute sa either masyadong mataas na result o masyadong mababang result. Yung tinatawag natin na false positive. That's why magkakaroon tayo ng issue on the confidence in the result. Of course, some of our system ay may problema sa detection tulad ng normally sa HPLC or even sa GC. Yung mga detectors dyan na UVBs or FID, they are called concentration sensitive detector, which means as the concentration of the analyte goes down, the sensitivity also goes down. Kung kaya, sa sample preparation, Max, can you please mute the dog? Yung tinatawag na sample enrichment, ito yung kino-concentrate niyo yung sample through sample preparation para pataasin yung concentration niya para mabasa siya ng system. Okay? So, you also would like to make the sample more compatible for any available system na pwede niyong gamitin for application or analysis. And of course, the ultimate goal is to make the laboratory more productive, meaning mababa ang lower of detection limit mo, mababa. So which means hindi ka magre-repeat ng mga sample and then more samples, less time. Essentially, you could minimize manpower and equipment maintenance. Now, if you look at this particular pie chart, makikita nyo that 62%, ang bottleneck talaga sa laboratory is actually yung 62% na sample preparation at saka yung 28% na data management. Okay? Yung collection is 4% lang sampling. And yung analysis only represent 4%. So, dito, it just show you na kahit na napakaganda ng binili mong equipment, lahat ng specification na inilagay mo is so very nice and very beautiful, pero wala ka pa ring idea how to prepare the sample, the bottleneck will still be there. Kaya malagi kong recommendation is before you proceed with purchasing any high technology instrument, please take into consideration sample preparation na kung saan gagamitin mong sample prep. Kasi I would still believe na kahit average lang yung analytical instrument na binili mo, pero you have a good sample preparation, laboratory will still be productive. Okay? Sabi nga natin, ang limitation sa mga sample preparation existing today is time. It's really time consuming. At ang problema pa sa time consuming, if you take more time, bago matapos yung sample prep mo, yung sample mo ay hindi na pwedeng i-analyze kasi nasira na. It also uses large amount of solvent, lalo na ngayon. At this particular point in time, now, noong dati, nung mga una ako nagla-laboratory, yung mga solvent, hindi gaanong concern. Mas mahal bumili ng solvent. Pero ngayon, mas mahal na ngayon na mag-dispose ng solvent. And then, it's also very costly. Time and solvent is also very costly. And very tedious to do sample preparation. I would like also to emphasize, the more steps you have in sample preparation, the more interference or the more issues or mistakes na pwedeng makuha mo. Okay? So, mas matahaba ang sample prep, mas magkakaroon ka ng mga problema. Now, before we proceed, please take into consideration ano ba yung sample mo kasi dito magmamatter kung what are you going to use. Ang sample mo ba ay volatile or not? Diyan kasi mamatter kung ang gagamitin ko bang technique is LC or GC, ano bang sample prep ang kailangan kong gamitin? Ano ba mga possible interferences? Okay? what analytical technique ba should I use? Okay? So, also, I would like also to point you out to this particular, let me put into my pointer. Okay? Mostly, ang magiging presentation ko is more on extraction. Okay? At this particular, mga selection ko ano pwede nyo gamitin for extraction preparation. Kakaunti lang yung clean up. Pero I would like to emphasize that the whole sample preparation procedure involves all of these three. Okay? Clean up at saka concentration. But I will concentrate more on the extraction kasi dito yung pinaka-critical. Well, nakapag-clean up ka, nakapag-concentrate ka kung hindi naman efficient yung iyong extraction. Okay? So, traditional sample prep. Yung mga traditional sample prep na, although there are two general types of sample preparation, liquid-liquid, liquid-solid. Yung mga traditional sample prep na ginagawa natin, particularly liquid-liquid extraction, mga Slit extraction, we know that they are time-consuming at saka it gets a large amount of organic solvent. Pero hindi siya obsolete. Kasi meron pa rin siyang mga application kung saan talaga pwede siyang mga gamitin. Okay? And of course, the purpose of course, makikita nyo during the process of the presentation na may mga nare-recommend ako rito ng mga probably instrument or automated system na pwede nyo gamitin for sample preparation because at the end of the day, ang objective natin sa sample preparation is to improve the accuracy of the analytical results and overall simplify the analytical procedure. Kasi I believe kayo bilang mga analyst sa laboratory, one of your main tasks is to be able to interpret, evaluate, and release results of your analysis para wala tayong backlog o walang tinatawag na, ang tawag dito, tama, backlog. Tulad ng, I know, alam naman ninyo na yung sa COVID-19 ngayon for RT-PCR analysis, mahaba yung, hindi man mahaba, pero yung may medyo tedious ang sample prep niyan, yung pagpa-transfer, pag-pipette, pag-react, and then yung results pa niyan, pag inilabas, kaya sabi nga nila, 12 to 24 hours ang results. Pero I would believe the bottleneck is on preparation ng sample, but you know for a fact that there are robotics that could do that. Na iwanan mo lang yung sample mo, let the robots do it overnight, bawas pa yung intervention ng tao. Okay? But anyway, so hindi yan ang i-discuss ko dito. So, ano ba yung mga challenges sa food safety analysis or any other analysis for that matter? Analytes are very low in concentration. And sample matrix is very complicated. Okay? So, let's start. The content of the discussion that I will be doing for today would be probably just be highlighting on most of this. Okay? So, papadaanan ko lang naman itong mga to. Where is my pointer? Padadaanan ko lang siya. Very, very brief. Tapos tignan lang ninyo kung baka pwede yan magamit or whatever. So, the first part, yung liquid-liquid extraction, an application which is basically separatory panel analysis. And then siguro medyo mahaba-haba yung discussion ko. Nang kaunti lang naman, overview ng mga liquid-solid extraction. Yung pinakauna dyan, yung shake flask extraction, very popular, very simple. Ito yung regular na ginagawa natin sa pharmaceutical. Slit extraction. Then I will also tackle a bit about PLE at saka ASE, and then kaunti sa SFP, and then yung mga microwave assisted, ultrasound, and then yung pinaka-popular ngayon na catchers, and then yung combination ng PLE at saka catchers, which makikita nyo sa ngayon ito yung may parang nag-gain ng popularity basically because it combines extraction as well as concentration. And then yung concentration na SPE. Then I will also touch a little bit about gas phase extraction, SPME, purge and trap, head space, thermal desorption, and some automation. Probably I'm not going to discuss for pyrolysis kasi ito very selective lang naman yung application. Okay, so let's start. So, liquid-liquid extraction. Pamilyar kayo dito, gumagamit ng separatory panel. Kailangan merong distribution ng miscibility sa polar at saka non-polar, oil at saka water-based. Kailangan nila maghiwalay para ma-separate nyo yung analysis and then you could run. Ano ba yung mga normal na pinagagamitan dito at this point in time? If you are doing HPLC analysis of water, fat-soluble vitamins analysis, part of your application probably deals with this, yung tinatawag na liquid-liquid extraction, na yung sample siguro pinapartition ninyo between and hexane layer at saka water layer. So pag na-partition nyo yung inyong mixture ng vitamins, mapupunta sa hexane layer, yung inyong water soluble, and the other hexane layer yung fat soluble rather, and then sa water layer nyo, dun mapupunta yung inyong water soluble. Advantage of this one is this is wide available. The materials that you need only is yung tinatawag na separatory panel. Okay? So very low recoveries, limited and time consuming. And then ito yung mga combination, just in case you would like to understand ng mga combination, you can use either pure water, itatandem mo siya sa any aliphatic hydrocarbons, hexane, pentane, or whatever. And ang acidic solution, pwede mong i-partner sa ethyl ethers or any other esters. Basic solution, ito yung mga may sodium hydroxide, whatever, pwede mong i-partner sa methylene chloride. Ito mga to. So ito yung mga any partners na pwede mong gamitin. Okay, now, meron bang past rule dito? Wala. Generally, ang normal na ginagamit ko rito is normally pagka hindi ko naman alam kung may acidic or basic compound doon, which malalaman ko lang kung meron is kapag yung aking liquid sample is sinubject ko sa pH meter, medyo mababa ang pH or mataas, then I could select any of these compound. Pero kapag talaga nasa 6 to 7 lang naman siya, then I just use pure water and at the same time any aliphatic hydrocarbons. Put in on the sample and then shake and shake and shake and shake and shake. Then separate. So this one I could provide you. Kaunti lang naman itong parang ang tawag dyan, flow chart for liquid extraction. I can give you a copy para for you to study kung paano yung pagkakasunod yun, how you would like to do this, the selection of your liquid extraction. Okay, so let's proceed to solid liquid extraction kasi medyo marami rin ito. Solid liquid extraction, sometimes they call it leaching. So ano bang purpose ng leaching is the removal of a constituent from a mixture of a solid by bringing the solid material into contact with the liquid solvent that dissolves this particular materials or these particular components. Karamihan ng mga sample prep natin sa food safety, dito pumapatak sa solid liquid extraction. So, pipili na lang tayo ngayon kung ano pa yung pwedeng gamitin natin at the moment. Sa ngayon, pagka you are tasked to do solid, tawag yan, food safety analysis, bumili ka, how do you call that? Binigyan ka ng budget, binigyan ka ng pera ng gobyerno or whoever in your laboratory, binigyan ka ng pagkakataon to buy a very high technology GCMS, LCMS, and then sabi nila ang sample mo is food safety. So ngayon, ikaw na ngayon na magdi-determine what you should do. This one also, I'll give you a copy of this particular tawag dito, ng flowchart para makita nyo. So, ang pinaka-popular, yung shake flask extraction. So ito, if you are in a pharmaceutical industry, ang sample mo ay tableta, weigh the tablet, ilagay mo yung tableta sa Erlenmeyer flask, lagyan mo ng suitable solvent, shake them, shake and shake and shake. Pagkatapos mong i-shake, it's either you try to centrifuge para bumaba yung liquid part or solid part rather, and then filter mo siya. After filter, pwede mo na siyang i-inject sa HPLC or sa GC. Okay? So that's ganun kasimple yung shake flask extraction technique. Okay? Meron din akong dating ginagawa na ganito, yung parang screening ng residual antibiotic sa meat. So yung meat, ang ginagawa ko sa meat sample ay piniprepare ko muna, which means chop mo muna siya, gagrind. Pagka-grind nito, ilalagay mo lang siya sa plastic, just put it in the freezer after maybe a day or two. Pag siya ngayon nagto na, yung tubig na nagto, yun ngayon ang ginagamit po for injection. O sometimes nag-add ako ng additional na liquid, pagkatapos shake, and then filter. The point there is, kapag ka-freezer mo siya, nagsuswell yung mga cell niya, pwedeng lumabas yung liquid. Now, again, the main task in a liquid solid extraction is yung tinatawag na leaching process. Yung solvent mo dapat pumasok sa solid part, the liquid part of your extraction solvent, papasok sa solid part, and then yung solid part, kung ano yung active component na gusto mong extract, ma-extract siya. Okay? Now, shake flask extraction may not be the most effective way because of some problem yung tinatawag natin na penetration ng solvent. Kasi nga, wala ka namang ini-employ dito na heat. Talagang shake lang ito. At pangalawa, yung surface area. So, kailangan talaga i-grind mo yung sample. So, dito pumapasok yung Slit extraction. Okay? Sa Slit extraction naman, yung mga normal na gumagawa ng fat extraction application, you extract, I'll show you maybe later. One of my colleagues will explain to you some of the automated thing. But in a Slit extraction is pinadadaanan mo yung sample mo ng hexane or any other na non-polar compounds na paunti-unti hanggang ma-extract yung gusto mong active component. Ang isa sa mga popular application nito sa semicon, yung sa analysis ng mga flame retardant, mga analysis sa plastic component. Kasi yung plastic component, alam natin naman yun is medyo matitigas siya, at saka yung mga nakadikit doon na kailangan screen for flame retardant, hindi mo naman makukuha sa isang extraction lang. Dahan-dahan talagang ina-extract yun. So sometimes it takes 24 hours doing Slit extraction. But anyways, meron naman na ngayon mga pwedeng aabot lang ng mga 30 minutes, 60 minutes by yung tinatawag natin na semi-automatic or automatic Slit extractor. But later I'll show one of my colleagues will explain to you kung ano itong mga difference ito. At the same time, as I mentioned to you, I'll give you a copy of flowchart para makita nyo. Just like in this particular slides, sometimes your extraction you would only take 60 minutes or 20 minutes for Slit extraction. Okay. Now, anong difference ito sa Shake Plus? Sa Slit, mayroon ka ng inad na heat. Nagdagdag ka na ng heat. Kasi di ba ang purpose ng heat, pagka naglagay ka ng heat sa solvent, ang viscosity ng solvent bababa. So kung bumaba ang viscosity niya, it will diffuse inside the sample at ma-extract niya. Now again, bear in mind as well, ang isa pang bottleneck natin sa sample preparation is yung selectivity ng extraction process. Kasi sa Shake Plus, even dito sa Slit, extract mo talaga lahat depending on the strength of the solvent. Kasi yung strength ng solvent na ina-apply mo, fixed naman yun in a particular condition. Like for Slit, nag-apply ka ng heat 60 degrees or 80 degrees, the strength of the tinatawag na solvation power or extracting power ng solvent mo become fixed based on the particular heat that you apply. Kaya dun sa Shake Plus, wala ka namang in-apply na heat. So, ganun din. Yung selectivity niya ang issue mo. It's either very strong siya or very weak. Okay? Kaya, naghahanap tayo ng mga additional. Dito ngayon papasok, I'm not sure if you're familiar with this technique, pressurized liquid extraction. Okay? Or accelerated liquid extraction. Alam ko sa yung mga gumagawa ngayon ng environmental analysis, particularly sa EMB, analysis siguro ng mga polychlorinated biphenyls, yung mga tinatawag namin na very hard to extract, gumagamit nito. So ano ba itong sistema na to? Okay? So, this is may kasama na itong instrument. Bakit meron na siyang kasamang instrument? Because going back sa Slit, may kasamang instrument. Bakit nag-apply tayo ng high temperature? Dito naman sa pressurized liquid extraction, nag-apply tayo both ng high temperature, kaya may makina ka na because you have to put all the system on an oven. At the same time, nag-apply ka ng pressure. So dalawa na ang ina-apply mo ngayon. Bakit? Kasi ang kinokontrol mo dito, yung solvation power or yung dissolving power ng liquid. Let me point to you into this particular diagram. Okay? Meron tinatawag tayong triple point. Itong triple point na to, if you apply certain temperature and pressure, alam naman natin, di ba? You apply a pressure to a particular compound, putting the temperature to be at constant, mag-apply ka na mag-apply ng pressure, a compound becomes solid. Or you maintain the pressure, constant pressure, and then you apply temperature and temperature and temperature, the thing become gas. Pero at triple point, kung saan mo nakuha mo yung sweet spot ng application mo ng pressure at the same time temperature, it becomes liquid and stay as liquid. So habang ini-stay mo siya na liquid, kahit na tumaas pa yung boiling point. Kasi di ba pag pinataas mo yung boiling point but stays as a liquid, yung viscosity goes down. So if the viscosity goes down, mas magpe-penetrate siya sa mga sample mo. Okay? So I would like to emphasize this particular thing. Increase mo man ng increase ang temperature, tataas yung boiling point, the liquid mo, hindi siya mako-convert into a gas but will continue to be liquid. That's why solvation power increases. Pag nag-increase ang solvation power mo, extraction efficiency mo increases at a less possible time. Okay? So, again, higher pressure causes solvent to remain liquid, as I mentioned, to penetrate sample matrix. Okay? Higher temperature also disrupt the strong solute matrix interaction. Babawasan kung ano man yung matrix mo para yung compound na gusto mong extract, ma-extract. It could improve the extraction process. Okay, so ano ba yung mga steps? The component of a PLE is like this. So meron kang pump, kasi nga makina na to, ang purpose ng pump mo is to pump in your solvent going into the oven. Dito mo na ngayon ilalagay yung iyong sample. Meron kang tinatawag na vessel. Okay? Then, dahil meron ka nagpa-pump ka ng solvent, as you pump in the solvent, if you close this, nag-a-apply ka ngayon ng pressure. Pag nag-apply ka ngayon ng pressure, I also apply heat here. So meron ako ditong pressure at saka heat at the same time. Okay? Dalawang paraan ng extraction. I could probably do dynamic extraction or I could do static extraction. Yung dynamic extraction, pwede kong i-close and then yung solvent ko pwedeng, let me see. Where's my pointer here? Okay? Yung solvent ko pwedeng umikot-ikot lang. Ikot-ikot lang yung solvent. Okay? Bakit? Kasi nagtitipid din ako ng solvent. Habang umiikot-ikot yung solvent, tapos na ako mag-extract, I can open this, then I can collect now the vial here. Now, para saan yung purpose ng nitrogen? Para i-sweep away, and then at the same time, pwede ko magamit din yung nitrogen to concentrate my analyte. So kung ano na-extract ko dito, pwede ko nang i-concentrate. Now, the good thing about this particular technique, mapipili mo yung solvent. Pero again, you have to go back to the basic chemistry. Dapat alam mo kung anong solvent na gagamitin mo for a particular extraction. But anyway, this particular technique, in-increase mo ang temperature at saka pressure, kaya medyo mas maganda yung efficiency ng extraction. Okay? So, you load sample, fill the cell with solvent, increase temperature and pressure, pump the solvent into the cell, purge with the cell, and then collect. May dalawang very popular ngayon na available, FMS and then ASE. Ano ang advantage ng FMS? Ang FMS is actually highly developed now and it is being recommended, I think, by a United States Environmental Protection Agency. So kapag ang sample mo, you're dealing more with environmental sample, PCB, extraction analysis, tapos dioxin extraction, PMS I think is more recommended. Pero sa mga food safety, itong ASE, Accelerated Solvent Extraction, is pareho lang siya ng PLE, pero ito is more on, I think, sino bang gumagawa nito ngayon? Thermo, I think, Thermo. Dati itong Dynex, but it's now being used as Thermo. The advantage nito on the instrumentation part, kita niyo itong part na to, you can put more sample. I'm not so sure how many samples you could put, pero pwede mo siyang i-automate. Okay? So, ang difference lang nito din, the same thing nakita nyo kanina sa PLE, you load, cell load, and then you fill, heat equilibrate, you can do either static, and then you can rinse and purge, and then ready for the next extraction. So, the good thing about the ASE, pwede kang mamili ng solvent, you can combine, you can mix the solvent. Okay, so, ano yung advantage na nito ngayon? From solid, from shake flask, walang heat, tapos pumunta ka sa Slit, may heat. Dito ngayon, meron ng pressure. Tapos, because you are under instrumentation, ano yung nagiging advantage pa? Because you're under specific instrumentation, pwede mo na ngayong i-select yung mga solvent na gagamitin mo. So, depending on the polarity or ang tawag dyan, hydrophobicity ng solvent, pwede mo ngayong paglaruan yung strength ng solvent by combining them. So, ngayon, meron ka ng mass control. Okay? Then there is another thing. I'm not sure if you have, I was probably, ang tawag dito, nagkaroon ako ng pagkakataong gumamit itong extractor na to or chromatograph. Yung tinatawag na supercritical fluid extraction. If you look at the particular construction nitong SFE or SFC, pag sinabing SFC, may nakakonect ka na detector para pwede mo nang pagka na-extract, pwede mo nang i-analyze yung result. So ang difference nito is if you look at this, from the triple point, in-increase hanggang sa critical point. Ano yung ibig sabihin ng critical point? Yung liquid solvent mo ay pwede palang i-convert into a supercritical fluid. What it means, as you increase pressure and you increase temperature, at certain point, magkakaroon ka ng critical point where your particular solvent na ginagamit exists either a liquid or a gas. Ang tawag ay supercritical fluid. Ano ang advantage if a particular solvent exists as a liquid? Meron kang solvation power. Ano naman ang advantage kapag it also exists as a gas? It penetrates. So in this particular case, dalawa lang uli ang paglalaroan mo, pressure and temperature. And in the case of supercritical fluid extraction, nawala na yung variable na pipili ka ng solvent na gagamitin mo. Ano kaya? Ethanol, hexane, or whatever. Nawala na yun kasi kapag gagamit ka lang ng organic solvent, hanggang dito ka lang sa triple point. Pero at critical point, ang choice mo na lang ngayon dito based on the available instrumentation now is carbon dioxide. Yung tinatawag na natin na liquid CO2. Ilalagay mo lang ngayon yung CO2 mo, kaya nga tinatawag na liquid CO2 because it exists as a liquid or a gas. Yun na lang ngayon ang ginagamit mo na solvent for extraction. So let's look at this. Ano ba yung mga properties ng SFC? The liquid likes densities, di ba? It's 100 to 1,000 times greater than any gases. And it has a greater diffusibility and a very good solvating power. It reduces surface tension sa sample mo. So ano ibig sabihin ng pag-reduce ng surface tension? Kasi minsan if you apply heat and temperature, nagkakaroon ka ng cell disruption. At pag nagkaroon ka ng cell disruption, sometimes, imbis na ma-extract mo yung analyte na gusto mo, nagkakaroon ka ng secondary metabolites or degradation, dumadami ang peaks. Okay? Low viscosity, 10 to 100 times less than a liquid, and it's very good for compression. Okay? So again, nabanggit ko kanina, anong difference silang dalawa? Nawala na ngayon yung selection mo ng ano bang solvent. Ang gagamitin mo na lang, supercritical solvent, o tinatawag natin na CO2. Okay? How does it work? Ops. Hanapin ko muna yung aking screen pointer and then a pen. Okay? So, ganun din, makita nyo, di ba, meron pa ring pump. Pero yung iyong pump ngayon, dalawa na. The main pump mo ngayon is actually ginagamit mo for pump ng liquid CO2. Meron siya dapat coolant. Bakit? Dapat ito malamig. So, the same thing sa PLE na nakita mo, lalagyan mo ngayon ito ng sample. You put in the sample here, and then, dalawang pwede mong gawin. Pwedeng direct extraction without modifier. Okay? Ano ibig sabihin ng without modifier? Hindi mo lalagyan ng solvent. Okay? Ang purpose lang kasi ng modifier para mapaglaruan mo yung solvating power ng CO2. So what happens is like this. Pag nandiyan na yung sample mo, you pump in a liquid CO2. So ano gagawin ng liquid CO2? Kapag kasinara mo to, which yung tinatawag natin na static extraction, ikot-ikot lang dito ngayon yung CO2 mo. So yung liquid CO2 mo, in-extract niya ng in-extract yung sample. Once na ma-extract na yung sample, pwede mo na siyang palabasin. Paglabas niya ngayon dito, liquid pa rin siya, ha? Liquid CO2 pa rin siya. Now, pag ni-release mo na siya sa restrictor, the liquid CO2 becomes, kasi ma-expose siya sa atmosphere, di ba? It becomes CO2, it evaporates, ang makukolect mo lang sa buyer is your extract. Magiging siyang very pure kasi extract lang ang makukolect mo dito. Kaya dapat, sa collection vial, meron kang suitable solvent to trap in yung tinatawag na analyte. Okay? Now, otherwise, kung ayaw mo naman, which I had a chance to use this particular technique for yung extraction ng essential oil, yung mga lagay mo dito na whatever, probably peanuts or almond or whatever, kikita mo yung lumalabas dito sa this part is just the oil part. Okay? Now, let me see you some of the instrumentation. Okay? This particular thing is called a company, Sepiatech company. Dalawa yung pwede niya. Itong isa na to, this is a extractor. Ito ay chromatograph. Bakit chromatograph? Kasi may nakakabit ng detector. Pwede mo na ngayong paglabas ng analyte, pwede mo na ngayong i-run dito with a column. Meron ka ng chromatography. Okay? Dito, extract mo siya. Pagka-extract mo dito, i-inject mo ngayon sa HPLC or sa GC. Now, bakit sa ngayon hindi wala pa gaano maraming gumagamit nito? It's because medyo mahal yung instrumentation. At the same time, going back, yung tinatawag na optimization ng yung optimization ng temperature at saka pressure is very important. At the same time, optimization ng release ng restrictor. So kapag hindi mo to na-optimize, sometimes magkakaroon ka ng issues sa reproducibility of the results. Okay? So next. Meron tayong tinatawag na microwave-assisted extraction. I'm not sure if you have been able to use this. Kaya ano ba yung microwave? Later on, I will pass you to my colleague to show you kung ano ba itong mga microwave. Microwave is a normal microwave oven na meron tinatawag na microwave hertz. Ano ba to? Yung meron siyang direct action of wave materials in your sample. Kung meron kang direct action, dire-diretso lang, targeted yung heating na ginagawa mo. As kumpara, let's go back to Slit. Sa Slit yung heating mo, hindi man targeted kasi ang hinihit mo dito yung solvent. Dito, because you're targeting the heating, pwedeng mabawasan mo yung gamit mo ng solvent kasi targeted ang heating na ginagamit mo rito. And basically, there is no lost heat to the environment. Kaya mas efficient ang extraction, mas bawas yung time of you doing the extraction. Okay? So sabi nga rito, the unique heating mechanism significantly reduces the extraction time, usually less than 30 minutes compared to Slit. So pagka nagsusok-slit ka ngayon at gusto mong pabilisin, maaaring ito yung isa sa mga solusyon na pwede mong hanapin. Okay? So ito yung mga, how does it works? The MBA process is, you apply a microwave radiation. After that, the moisture gets heat up. Yung moisture sa sample mo. Pag nag-heat up na yung moisture mo, the moisture probably evaporates and magkakaroon ka ng pressure on the cell. This particular pressure will induce the extraction ng cell wall. Mag-i-induce siya ng swelling of the cell and then rupture of the cell and then leaching out of the constituent. Okay? So mostly, fat extraction process pa rin ito pero mas mabilis. Okay? So this phenomenon can be intensified with solvent with higher heating efficiency under the microwave. Okay? So dalawang system siya. You could either use open system, which means may ganito ka sa kabila, or the other one, closed system. Sara mo, bubukasan mo na lang kapag na-extract na, then you just filter. Okay? So sample lang ito ng mga microwave extraction as compared to conventional extraction from 55 minutes to 4 minutes, from 50 minutes to 5 minutes, from 60 minutes to 5 minutes, and then from 75 to 4. So pinabibilis talaga niya yung extraction process mo. Okay? So we are representing a company called Cineo. So itong isa nakikita mo rito, this is open and dito yun naman yung close. Okay? Now, the same ito yung ginagamit sa digestion ng ng tawag dito ng sa AAS. Pero of course, if you paglaruan mo lang yung microwave power nito, pwede mong gamitin ito for other digestion purposes, not digestion, sample preparation purposes of organic compounds. Okay? Now, there is another thing also called ultrasound assisted extraction. Ito, nakikita ko rin, karamihan ginagamit ito ng mga analysts sa pharmaceutical lab, even sa ibang general laboratory na ginagamit nila yung ultrasonic bath nila to dissolve a particular sample. So, yung tawag doon, cavitational phenomenon. Di ba? Pagka naglagay ka ng sample sa ultrasonic bath, nakikita ka ng maliliit na mga bubbles. It's the sound that disrupt the cell. So, pag na-disrupt siya, ma-extract yung gusto mong i-extract. Okay? So diffusion to the cell wall and then it releases cell content after the walls is disrupted. Okay? And then ultrasound create bubbles hanggang ma-extract siya. Now, two ways na pwedeng itong gawin. Meron tinatawag na yung parang probe ang ilalagay mo. This one is paisa-isa yung sample mo kasi may probe ka na ilalagay. Pero mas itong probe na nilalagay mo sa sample mo, mas concentrated ito. Mas maganda yung efficiency nito kaysa doon sa ultrasonic bath na ilalagay mo yung sample mo. Okay? So kahit sa anong paraan, proseso, before ma-adapt mo yung microwave digestion microwave ultrasound assisted extraction process, of course, please make sure na na-validate mo to using your methods validation process. Okay? Pero it helps. Now, moving forward, let's go to this another one, catchers. Ano nyo itong catchers? This is now very popular sa environmental laboratory at sa food safety laboratory. Although this one is initially developed para sa environmental analysis, yung mga extraction ng pesticides, pero marami na rin po itong gamit sa food safety. Ginagamit na rin po ito sa extraction ng mga mycotoxin. Kapag may mycotoxin sa mga tawag dito, you have some mycotoxin sa corn, and then you want also to analyze polyaromatic hydrocarbons in oil. Pag ginagamit na rin po ito. Okay, so ano ba ibig sabihin ng catchers? Quick, easy, cheap, effective, rugged, and safe. Okay, so itong catchers na to has been developed by dispersed people. Okay, in 2003, so bago lang. So essentially, ginawa talaga nila ito for pesticides at saka vegetable and fruits. Extraction of pesticide ito sa vegetable and fruits, and then this is now widely used kahit nasa pharmaceutical, clinical, environmental, extraction, or whatever it is kasi it also works. And dahil nga itong mga to, may mga nabibiling commercial catchers, prepared na yung mga ginagamit na reagent, kaya mas mabilis. Okay? So the procedure has two main steps, extraction with a solvent and partitioning. Then clean up using a dispersive solid phase extraction. I would like also to emphasize, Yung clean up is up to you. Pwede kasing doon ka lang sa solvent at saka partitioning. After that, kung gusto mo magkaroon ng clean up using SPE, solid phase extraction, or proceed with dispersive extraction, nasa sa iyo yun. But there are ways to do this. Okay? So, this is normally yung ginagamit na alternative for liquid-liquid, alternative sa SPE. Okay? So, makikita nyo rito, if you compare this, mas 20 minutes ang extraction time lang, 10 to 15 ml lang ginagamit, at wala gaanong waste. And proven na ito that the recovery is very good. Okay? Now, how does it work? Normally, kapag ang sample natin, let's say that our sample is meat sample. So, i-dry, ang tawag dito, i-grind mo lang siya. So, how do you grind the particular sample? Ilalagay mo lang dapat siya into a grinder na may ice. Ba't kailangan may ice? Kasi kapag walang ice, yung grinder mo mag-heat up yan. Pagka nag-heat up yan, magpuproduce ka ngayon ng heat na hindi ka pa naman nag-extract, nag-evaporate na yung iba. Okay? So, how does it do? Again, after the homogenization of a tube, lalagyan mo ng solvent, normally acetonitrile, and then vortex them. After vortex, ilagay mo na yung extraction packets mo. After extraction packet, just shake them. After shaking them, use centrifuge. After centrifuge, pwede mo nang ilagay yung dispersive SPE. Pakalagay ng dispersive SPE. Vortex again, shake, then analyze. As easy as that. Less than 20 minutes, tapos na yung extraction procedure. Ganun siya kadali. Okay? That makikita mo lang, dito gusto ko lang ipakita na yung may mga ibang catchers na pwedeng maglagay ng ceramic homogenizer or pwedeng wala. So, nakakadagdag lang yung ceramic homogenizer sa cost. Kaya lang, ang kagandahan niya, mas nagbibigay siya ng paraan para mas ang dispersion mas mabilis. So, dito medyo mas clean as compared to this other one. Okay? So, again, yung original is invented in 2003 pero meron ngayong AOAC at saka EN. Now, anong difference lang nito as compared dito? Yung ginamit lang na salt. Ito ay hindi buffered, ito ay buffered. Okay? Magkaiba lang ng pH. Pero because alam naman natin if you're doing pesticide analysis for quite a long time, medyo mas mahigpit, ang environmental European Union ang medyo mas nagbigay ng emphasis diyan. Kaya if you are going to send your samples for approval sa EN, I would recommend you use an EN catchers for a particular analysis. Now, pinapakita ko lang din dito sa extract just for you to see na after extraction, medyo concentrated or medyo madumi pa rin ng konti, kailangan pa rin itong i-clean up. Pag hindi nyo ito na-clean up, dapat pag ini-inject nyo ito sa LC or sa GC, ang tawag namin dito, injection should be high volume. Sa GC, probably you inject 5, maybe 3 to 5 microliter. Sa HPLC, maybe 100 microliter para makuha niyo yung analyte of concern. Okay? So, again, merong ito yung pinapakita ko kayo ng iba't ibang salt na ginagamit for EN at saka AOAC. And then, ganun din sa AOAC at saka EN, 5.57. Kaya nga sabi dito, mas maganda daw yung pH 7. Kaya karamihan ng ginagamit ngayon, pagka magpe-pesticide, remember, lagi kong nire-recommend, please proceed with EN buffered method. Now, for other food safety application, extraction na halimbawa ng antibiotic, residual antibiotic sa meat, extraction halimbawa ng mycotoxin sa peanuts, ang minare-recommend ko minsan yung general purpose lang, yung original. Okay? And then, makikita nyo yung sa dispersive SPE, makikita nyo may iba't ibang component, magnesium sulfate. Ang purpose ng magnesium sulfate, mag-remove ng water. Apart from mag-remove ng water, ini-increase niya yung polarity ng iyong water para mas efficient ng extraction. And then yung PSA, yung tinatawag natin na primary secondary amine, it removes organic acids, also it removes also some water. And then yung C18, tinatanggal niya fats at saka lipid. Tapos yung GCB, granulated, I forgot, para sa removal ng pigment at saka chlorine. Lalagyan nyo chlorophyll, lalagyan nyo lang ito kapag ang sample nyo masyadong makulay. So you can select any of these, okay, na mga packets available. Okay, so may mga automated catchers na pwede kayong gamitin. Itong isa is from a company called Gerstel. Itong isa is from a company called ChemSpeed. Now, between the two, I would recommend ito kasi ito actually design ito na ikabit mo sa ibabaw ng LC or GC or ilagay mo na tawag diyan, ilagay mo na offline. Pero I would recommend using this one kasi mas maganda yung nito Although mas expensive siya, pero mas extensive yung mga makina nito. May centrifuge dito na available. Ito may centrifuge din, kaya lang mas maliit. Okay? Mas mahal lang ito, pero this is a very nice system from ChemSpeed. This is made in Switzerland. This is made in Germany. Okay? Now, let me introduce to you, this is bagong technique. Ang tawag dito, energized dispersive extraction. Pinag-isa rito, di ba na-mention ko sa inyo kanina, extraction, you can do extraction using PLE, you can do extraction using catchers. Pero dito sa technique na to, pinag-isa yung PLE at saka catchers, you can do extraction, cleanup, and maybe concentration at a certain point. And because it uses an energy called energies dispersive, nakalimutan kong ilang ilagay din dito. Kasama rin dito yung microwave because it uses a microwave power to increase the temperature. So, paano ba ang itsura nito? What happened to me? Ba't ayaw bumaba? Ayan. Okay? So, this is available from a company called CEM. I'm not sure if you have seen this. Combination ito ng pressurized liquid extraction at saka dispersive solid phase extraction. This is a sample na pwedeng kayong 12 samples, I think. And then 5 minutes lang ito. Solvent is only used, only 30 ml of solvent. Very compact. The cost, I don't want to say moderate ang cost kasi mahal din naman ito kahit papaano eh. And then after that, it actually filter the samples. How does it use? Ang technology niya is nakabase dito sa tinatawag na Q-cup. Ang selection mo ng Q-cup will determine kung anong sample na gagamitin mo. Maraming tubig, kaunting tubig, or whatever. So dito ka magsiselect. Ito yung pinaka-consumable nito. So what happened is, sa Q-cup, lalagyan mo ngayon, let me, nasa bawat. Sorry, nawawala yung aking pointer. Okay. Screen, pointer, pen. So what happened dito is, lagay mo yung sample mo rito, pakalagay mo ng sample, you can also put yung mga salt na for catchers, and then, pakalagay mo yung sample mo, ilagay mo ito sa cell, and then ipipressurize ito. Paano ipipressure? Kasi tinakpan. Pakatakip, yung solvent na nasa labas, o unti-unti niyang ipapasok dito sa loob. Habang pinapasok niya sa loob yung solvent, it will be energized by, some sort of an energy. I would think that was a focused microwave or whatsoever. And then, it will mag-adapt siya sa extraction process mo. After that, automatic na ngayon yung solvent na ginamit mo rito, automatic siya rin ngayon na i-release through this papunta sa collection vial. And from the collection vial, may nakaabang doon na nitrogen, or any other concentration process para mako-concentrate yung sample mo, then automatically you can inject. So what I'm saying here, meron ka ditong extraction, meron ka na rin ditong concentration, meron ka ng cleanup, meron ka ng concentration in one. Okay? So mga example lang ito ng kanila, ang edge daw is 5 minutes, 30 minutes, etc. Mas maikli lang yung time. Solvent usage mas mababa din. So in the long run, the cost is smaller. But I don't know, if you are more into doing automation part or whatever, you can look into this particular technique. I know this is a good technique. Again, na-mention ko, yung QDIS will determine ano bang kailangan mo, dry or wet. And then the dispersive, meron ka ring selection kung anong gusto mong gamitin for a particular type of analysis. So ganun lang siya, just assemble the Q cup and then takpan mo lang, lagyan mo ng measure the sample. After measuring ito una pa lang nilalagay dito yung mga extracting salt, and then lagay mo yung sample, and then no packing whatsoever, and then ito. So pinapakita lang dito after extraction na ito yung makukuha mo mga extract. This one, pwede mo pa rin i-concentrate. Okay? Now, moving ahead, after catchers, may SPE. Anong difference ng SPE sa catchers or dispersive? The principle is almost the same. Ang pinagkaiba lang sa dispersive, hinahalo mo na yung iyong analyte doon mismo sa extracting catchers, yung sa dispersive solvent, or dispersive salt rather. Sa solid phase extraction, it works like an HPLC. Paano nangyayari yun? Kasi yung iyong mga tube is look like an HPLC na kailan nakalagay sa isang parang syringe type. Itong particular na sorbent mo na to, pwede siya maging silica-based, pwedeng alumina-based, pwedeng polymer-based, pwede siya maging polar, pwedeng maging non-polar, pwedeng C18, pwedeng C8. So nagkakaroon ka ngayon ng selection. The main thing is, pagka naglagay ka ng sample dito, the main purpose mo for cleanup, number one, para sa cleanup, lahat ng interference, pwedeng matrap dito, ang lalabas lang dito sa baba, yung analyte mo. That's one way. The other way around is, for cleanup purposes also, pagka pinasok mo dito, maiiwan dito dapat yung analyte mo lahat ng dumi will go out and then tsaka mo na lang i-re-elute ng iyong suitable solvent. Okay? So that's how an SPE work. Now, would require method development? Yes. Medyo mahaba-habang, hindi man mahaba-habang method development kasi marami ng mga literature na na-adapt through this. I think, ang karamihan na gumagamit nito is yung sa forensic application, even sa food safety, maraming gumagamit nito. Now, I know for a fact na yung nakagawian ng gumamit ng SPE for cleanup at saka extraction sa pesticide, nag-move, I don't want to say nag-move away, pero nag-ship going to catchers kasi ang catchers mas mabilis. Anong pinagkaiba lang nila? SPE at saka dispersive SPE. I'll show you kung anong difference silang dalawa. Now, I mentioned ito yung process ng SPE. So, you condition the column. After condition, you load. After you load, you wash, you dry, and then you elute. Kung anong na-elute mo rito, inject. Okay? What is the other one? Oops. Ayaw na naman bumaba. Next. Ito naman yung DPX, yung tinatawag na dispersive. Ang difference lang, yung analyte mo, not the analyte, the solid phase ay naandito na sa loob. So what happened is, kukondition mo, after you condition, ilalagay mo na yung sample, aspirate the sample, and then mix. After mixing, tsaka mo ngayon i-discharge, then you wash it, and then elute, then inject the sample. Okay? So, ang difference lang nila is, if you look at it, yung SPE, andito sa loob, naiiwan pa rin siya. Okay? Nakapack. Ang dispersive, loose. Bakit siya naka-loose? Gusto mo i-mix thoroughly. Ano bang diferensya nila? Ito medyo malaki, ito mas kaunti. So ngayon, sa mga sample na concentrated, diretso na agad sa analyte or sa LC or sa GC, you can use this one. Okay? Whatever is the case is, may mga automated SPE na pwede kayong gamitin. Okay? Again, yung dispersive SPE, pwede siyang lagyan ng automation. There is a company called Chrome. This is based in Canada, na meron siyang offline SPE, mayroong online SPE. Again, dalawang klase ng offline SPE. Ito, automated na, siya yung naglalagay ng sample, siya yung naglalagay ng mga washing solvent, elution solvent. Yung isa, yung ginagamitan nyo ng vacuum manifold, ang na-automate lang doon yung pagsipsip. Okay? Kaya lang, I would like also to mention na ang malaking problema sa vacuum manifold extraction is pag hindi mo nakokontrol yung vacuum, nagkakaroon ka ng tinatawag na breakthrough. Ano yung breakthrough? Pati yung analyte na tinatrap mo lang, lumalabas na agad. Kaya, di ba, nagsiship karamihan ng gumagamit ng vacuum doon sa positive pressure. That's why, if you would like to do automation ng SPE, kasi alam ko kung bakit nagsiship yung iba from SPE to catcher kasi nga matrabaho. Okay? Ito, you would like to try an offline SPE. Itong isa, 8 position. Itong isa, I think, 16 position tsaka 32 position na offline SPE. Or if you want to do online SPE, pwede naman ganito. So, ayan yung SPE mo. I-clean up niya, paka-clean up, diretsong ini-inject sa HPLC and then analyzed by a mass spectrometer for online SPE analysis. Okay? Now, let's proceed to papahuling part ng aking system, ng aking presentation. This is automated GC sampling. Ito naman, automated extraction na ginagamit sa GC. Okay? Makita nyo lang yung mga differences. Unang-una, SPME. Ano ba yung SPME? Yung SPME, gumagamit siya ng tinatawag natin na fiber. Itong fiber sa ilalim. Yung fiber na to, pag kaya na i-dinip mo either nakadip dito sa sample or pag hinitap mo to, yung pag hinitam ko ito, magkakaroon ka ng mga volatile, pwedeng headspace lang. Yung analyte of concern mo, depending on what fiber you use, remember the principles like dissolved likes, yun lang ang didikit dito. Pag yun lang yung dumikit dito ngayon sa fiber, tapos na yung extraction procedure mo, pwede mo na siyang i-retard, paka-retard, pwede mo na siyang i-inject sa GC, tapos yung injector mo, may init siya, di ba? It will automatically dissolve the analyte going to the column. That's how simple it is. Okay, now, ano lang ang differential, what is the hard, ano yung mahirap gawin dito? Yung selection ng fiber. But anyways, ang selection ng fiber mo lang naman ito, maximum na ata ng mga 4 or 6, but then yung selection ng fiber mo would also depend kung ano talaga yung analyte of concern mo. Pero what I'm trying to say is, remember, sinabi natin, ang GC is a clean GC. Pwede nyo itong itry kapag ka nakakakita kayo for your GC analysis, medyo maraming interference. You can try SPME application. And the good thing about SPME, pwede mo siyang i-automate. We have a product called Flex. This is made in the US, kung saan isang autosampler, pwede mo nang pag-isahin yung liquid injection, you could also, pwede mong lagyan din ng headspace, pwedeng lagyan ng SPME sa isang autosampler. You can do this either offline or you can do yung online na nakalagay sa ibabaw ng mga GC. Okay? Headspace, I know most of you had been using this. Ang headspace is, and how does it works? Pag hinit up mo yung of course you have to cap it first. After you cap, pag hinit up mo siya, ang objective mo yan is kung ano yung concentration dito, dapat mag-equalize dito. So pag nag-equalize dito yung concentration ng volatile, pag sinaming equalize, meron dito, meron din dito. And then i-dissolve mo ito papunta sa GC for analysis. Okay? Saan ito normally ginagamit? Residual solvent sa mga packing material. Yung pagka binuksan mo yung kinakain mong chichirya, ba't kaya ito may amoy? Kasi may residual solvent. Saan ba ito pwedeng gamitin? Blood alcohol analysis. Lagay mo yung dugo mo dito para tinang kung may ethanol content. Ano pa? Halal application, halal analysis, may residual ethanol kayang ginagamit sa mga food products na to. Pwede mo itong gamitin. Okay? Itong headspace. And then there are two available headspace analyzer in us, yung tinatawag na, this is from Tecmar, I think. Itong isa ay limited lang yung number of vials at yung isa is you can do a lot of vials, but this one you can do static, this one you can do static and dynamic. Anong difference silang dalawa? Sa sampling lang. Okay? Now, moving forward, meron tinatawag na dynamic headspace or tinatawag na thermal disruption analysis. So how does it work? Yung I'll show you later sa susunod kung paano siya nagwo-work, but essentially ano lang to, parang headspace lang na tulad nito. So meron kang sample, yung sample pag heat up mo ng sample is dinideserve ng gas, yung sample na din tinatrap niya dun sa solid trap mo. After na-trap mo doon, and then pwede mo siyang i-heat up again, pagkatapos mo siyang i-heat up, and then it transfer directly to the GC for analysis. Okay? Kaya siya binabanggit ng automated GC sampling is, wala kang ilalagay mo lang yung sample, let it do the work. Saan ba pinakamagandang ginagamit ang dynamic headspace? Kung gumagamit ka ng headspace, gumagamit ka ng SP, magagamit mo rin itong dynamic headspace. I'll just give you an example. Example lang ito ng, normally this is analysis ito ng mga odors and flavors ng mga compound. Itong purpural, ito yung yung mga indication ito kapag ang produkto nasisira na. May mga amoy na itong mga part na to, no? So makikita niyo yung differences dito. Sa headspace, wala na siya nakikita, pero may makikita pa sa SPM at saka dynamic headspace. Bakit wala na? Kasi remember, sa headspace, pinapartition mo lang siya in the two. So hindi 100% yung extraction. May natitira pa rin dun sa vials. Kaya medyo mababa. So kung kailangan mo ng mataas na concentration for analysis, I would recommend you probably do dynamic headspace analysis. Okay? And then, there are two available system from us if you like to explore that particular application. May tinatawag kaming automated headspace at automated thermal desorber. Itong isa na to, meron na siyang autosampler. Of course, dapat yung mga sample mo dito na undergo mo na ng purge and trap, na trap mo na dito and then transfer it here before you proceed the analysis. Itong isa, single lang ito. Single sample lang. Okay? Now, kailan mo itatrap yung mga sample dito? Ano yung mga application ng purge and trap? Kung pwede mo ting gamitin ito sa normally sa arson analysis, di ba? Kung gusto mong i-test kung anong naging dito, nasunog dito, i-collect ko nga kaya yung mga usok dito sa sunog na to para malaman ko kung anong ginamit dito na accelerant. You can do that there. And also, you can also do this para sa analysis ng ambient environment, para sa occupational safety. Ano kaya mga amoy na meron dito na nalalaso na kaya yung aking mga analyst, nalalaso na kaya yung mga worker, you can do that. Once na matrap mo, tsaka mo ngayon iraran dito. Okay? And then, lastly, meron ding, this is not part of it, pero itong tinatawag na EST purge and trap for VOC analysis. Ito naman yung analysis ng volatile organic compound in water. Mandatory ito kapag meron kayong requirements sa analysis ng BTEX sa soil at saka sa water. I think the good thing about this is dapat i-undergo mo siya ng EST purge and trap analysis. Okay? So, my last part here is, before I entertain some question and before I ask my colleague to share some of his presentation, is the point na gusto ko lang bigyan ng punto if you go to sample preparation is you have to select automated or manual. Essentially, ang advantage ng automated is reproducible ang steps. So if the steps is reproducible, ang error na na-incur is also reproducible. Which means if you're doing relative analysis technique, ikino-compare mo sa standards, yung reproducibility of the results, pwede mo i-cancel out yung error niya dahil nga meron ka namang standards na ginagamit. So automation is still preferred over manual. Kasi sa manual, medyo mano-mano, pagka wala ka sa mood mag-sample prep, pangit ang result. Pagka nasa mood ka dahil maganda yung naging ano mo kahapon, maganda ang result. Okay? This one also is something to do with shorten extraction time and also reduce solvent energy consumption and also improve extraction efficiency. Nilagay ko dito sa kabila yung tinatawag na green technology kasi ito talaga yung move na ngayon eh. Kung hanggat may iwasan yung solvent, may iwasan yung solvent. Before I give you to my colleague Karamlin, gusto ko lang re-emphasize. I hope we would understand. Doon sa proseso ng aking sample prep, ang mga hin-highlight ko na pwede nyong i-select, yung mga sample preparation that would require very little use of solvents. Kasi ito talaga yung isa sa mga problem. And then yung fast analysis. Bakit kailangan ng fast extraction? Para kung may error man, you can just repeat it again. Hindi tulad ng extraction nyo, aabot ng 3 oras, 5 oras, or overnight. Pag-repeat mo naman, matagal na naman uli. And of course, at the same time, improvement of extraction efficiency. Okay? So, if you have a question, I would like to entertain them now if they have. Meron ba, Mets? Wala. Kremlin.
Wala pa, sir. Wala pa.
Right now, sir, wala yung nag-prompt nila for chat.
Okay. But anyway, you have some question we'll like to entertain if you have. Otherwise, I'll transfer you to Kremlin. Wala. Kung meron kayong gusto na some details on all of this, just send us a chat. Bigyan namin kayo ng detalye. Remember, this particular presentation, gusto ko lang magbigay ng overview para mabigyan kayo ng idea lang kung ano yung mga obra. O otherwise, I'll transfer you to Kremlin.
Okay na, sir?
Okay na ako. You proceed.
Okay. So, good morning to all. So, this is just 15 minutes for the discussion of the system that we have now. So, dalawa po ito sa mga klase ng ating for sample preparation. So, first, I'll be discussing about yung aming extraction system. And I believe most of you already familiar with this Slit method. Okay, so just to show you, this is the overview of the application for the extraction system. As you may see, mostly here are under our feed, food, soil, and the other part here at around 3 o'clock. So ito yung 21% natin that the said technique being done under chemical industry, testing facility, as well to do some analytical, chromatography, volatiles, sample preparation. Okay? We all know that the Slit method is the history technique for doing the oil or fat content of sample natin. Okay? And this is just to show you, that's the last part, that Slit method is also one of the common sample preparation doing chromatography, as I mentioned a while ago, the elemental at the same time the volatiles. Now, the good thing about the brand we have now is we have 2 options depending on the application, depending on the sample, okay, analysis. And our unit actually accommodate even all kind of solvent, be it as harsh as toluene, as the commonly yung ating pet eater, and hexane, and others known solvent to be used. Okay? Now, this is the typical setup of the extraction system at different laboratories depending on their application. So, commonly in traditional way or yung primitive method natin, ito yung tinatawag nating glassware type. Okay? Let me show my pointer here. Okay? So, this is the glassware type. So, it's just simply, you have here a simply water bath with those concentric rings and this kind of setup. Okay? And then, there are also known as semi-automated na kung saan siya po ay two-placer. And also, the Hanon, they have this what we call the semi-automatic six placer, as well as we also have this fully automatic extraction system. Okay. Now, this is of course for the cheapest and cost-effective. For a very simple application, we have this what we call the traditional glassware setup. Okay, but as you may see, this is have a very poor security setup, especially with after a couple of months or years use, na yung ating mga gamit ditong tubing will definitely worn out. At the same time, if you look closely at the bottom bezel touching those concentric rings. Okay. Now, by using with our semi-automatic unit, the benefit of this, so first of all, this is actually CPU-based temperature control. Okay? So, you have also here these individual knobs. Should you have around less than 6 samples that you want to extract. Okay? And then, this is actually our top of the line model. This is actually our fully automatic extraction system setup. Okay? Because this is actually for unattended operation. So meaning the analyst can have their other time to do some lab works. Okay? So first of all, this is made of glass and PTFE. Okay? And with the use of PTFE and glass, so eto po, because we all know at the extraction system, this is a weight by weight technique. So there are some kind of low cost kind of Soxlet setup wherein particular component of the Soxlet system chip off some powders. Kaya minsan pag recover nila when do they back weigh for the supernatant extract, so sometimes die. Okay? And that's the benefit of using the PTFE. And this one, as you may see at the left hand here, since we all know na ang Soxlet po ay pinaiinit na solvent, which is almost in vacuum, so our electronic or the control panel is just residing on the wall. Actually, this is a magnetic siya na nakatouch lang dito. So, pwede nyo siyang tanggalin. Okay? And by the way, this is powered by Android. So, very simple to use. And it's also a programmable that you can also define whichever kind of extraction and recovery setup you want. So we have 5 extraction modes. So be it for fat analysis, be it for continuous application. Okay? And these are the benefit of the system because since this is using the graphite heating mantle, okay, you have also the online or actual temperature monitoring. And I believe we are the only brand who have this what we call the ether leakage detection alarm. Because there's a sensor in the upper part on this area. Whenever there's a certain ppm sense for the leak of pet ether, automatically the heaters get off. Okay? Hindi na po siya mag-continue. Okay? And then also, if you may compare to our usual glassware setup, there's no way for you to monitor for the efficiency ng ating water flow within this one. So it's really an assurance for the repeatability of result because even the water pressure is also being monitored online. The analysis won't proceed unless all the all the sample containers will be in place snugly. Because every time that the system detects there's not sitting properly for a particular cup, automatic po, it won't start your analysis. Okay? And then also being an automatic model, so you also have the solvent recovery system. So because we all know in traditional glassware setup, sometimes the company need to invest for the what do you call this? For the rotabap, only for the purpose to recover with this. So unlike to this one, after the analysis, all you have to do is just place again your 6 cups empty and then just press the recovery and then it can now be used into your second or on the next analysis. Okay? So I have here a simple table list of what are actually the trade-off of using the glassware setup for extraction at the same time with instrument or being at a semi-automatic or fully automated model. Okay? Now, I have here the exploded view of our system. So as you may see, so this is the location for the ether leak. Okay? So this one, material which is made of glass and PTFE. And in the right side of the unit, facing the unit, nandun po yung ating panel to do our configuration at the same time methods to be used for our extraction system. Okay? And the good thing about this automated system, so it can actually handle even if you have may mga analysis po tayo that really requires around 200 or more than 200 or less than 300 degrees Celsius. And our temperature control accuracy is plus or minus 1 degree. Okay? And then another thing, especially on certain analysis requiring larger sample. So with the hand-on extraction system, you can even work into a particular solvent requiring more than 100 ml. Okay. And by the way, if it's usual time, because usually for the glassware setup, it's 8 to 16 hours of doing the extraction, as compared to the automatic model as 2 to 4 hours of analysis. Okay, so that's all for that software extraction, and then my last part will be the microwave digestion system. Okay, so microwave digestion, actually this technology has been around since 1970 because that time they also want to analyze the presence of some volatile elements like the mercury and other mentioned, and that's the limitation of the conventional heating mantle type. Okay, for the microwave. So for the microwave digestion, it is a closed vessel technique. Okay, so this is irradiating by the use of microwave, and with this kind of closed at the same time irradiation, it actually increases both the speed of the composition of your sample, mostly of the organic component natin. Okay. Okay. So as mentioned by Sir Lemuel, mostly po talaga nanineglect ng laboratory is with the pre-treatment, and it's actually stated here in this graph. Okay, so these are the different applications for microwave chemistry. So the one that Mr. Lemuel presented, that is actually one example of our microwave digestion. Okay, and then it's commonly used under these industries. Okay, be it for the inorganic, organic, life sciences, and other studies. Okay, what is microwave? So remember our electromagnetic spectrum. Okay, so the lowest energy here resides under radio waves, and then our here the X-rays at the left part. So we all know it is called microwave because it is much more smaller than radio waves. Okay, so what actually happened at this one, at the microwave, the tendency of this particular molecule is to make a rotation. Okay, and under infrared, the tendency of our molecule here is to do the vibration. And of course, the X-ray, it's much more deeper. Okay, because microwave is the only part of the electromagnetic spectrum capable to penetrate even food and other non-food sample as compared to these items. Okay? And it follows this. Kung natatandaan nyo pa po yung ating Fleming's rule, our left-hand rule. So what happened is for every radiation of this propagation, the perpendicular o yung nasa hintuturo natin, siya po yung ating electric field. And the one that's on yung sa middle finger natin, if you're making now the left-hand rule or Fleming rule, So you have this magnetic field. Actually po, etong magnetic field na to ang present dito sa ating sample na kung saan dito po siya binabangga o highly binobombard ng ating magnetron which is coming from the unit of microwave digestion system. So the tendency of this particular molecule is just to rotate. And we all know that if you try to move ng mas mabilis, of course it gives off heat and actually it disassociates those particular species. Okay? So this is actually what happened inside our unit here. Okay? Which I'll discuss. Okay? So we have our oscillating field. This is actually the one generated from the laboratory microwave digestion system. Now, with the presence of those dipole into your sample, the tendency of this is to move actually this way. And there are some inorganic sample na ang tendency naman nila, pag tinamaan po sila or they absorb a microwave, the tendency of their movement is upward. This one is around medyo naka-incline po siya. And that's actually what actually happened, especially to those participants na may already using na microwave digestion technique. So that's why it only takes a certain minutes rather than couple of hours to do the elemental digestion. Okay? This is just a comparison if you're just using your ordinary hot plate. Okay? So we all know at hot plate, just like cooking our food, so apply your heat here, and then this material here will now do this convection current going to that sample. Okay? Unlike on this area, dito sa ating microwave digestion, so this microwave goes into those particular molecules, and with the presence of those dipoles, polarization, so what actually happened there is the release of this energy, and particularly mapapansin niyo po, 'di ba, napapansin niyo rin sa microwave pag nag-microwave ka ng kanin or pansit, technically the food gets hot rather than its container. Okay? Also, this is a thermal image comparing, this is the conventional oil bath. So you'll all know if your certain tube, if you want to digest here, technically even the upper or the head space above the particular sample also got hot. Unlike this one, if you subject it inside the microwave system, definitely all the heating only occurs into this particular region on the sample only. Okay? Okay. So this is to just give you an overview how does simple microwave digestion works. So basically, you have here around 0.5 gram of your sample, which is to be ground in less than 1 mm mesh size to pass through. And all you need is a nitric acid of around 6 ml and hydrogen peroxide of around 0.5 ml. Hydrogen peroxide is commonly used, especially if those have fats and other organic presence. Okay? And once you put it in all the system, all you have to do is wait for 15 minutes and now it's ready to do your elemental technique. Okay? So the unit is capable up to 12. Initially, it can be purchased of around 10 pieces glass vessels only, pressure vessels only, and optional for 2 components if you want to. Okay? And since this is also made of PEFE material, this actually can work or even can withstand even for a pressure of 1,500 psi. Okay? And we're actually using a piezoelectric for the pressure monitoring, which is capable of 0.01 Pascal. Okay, now, we all know that hindi naman po tayo pwedeng gumamit ng temperature wire inside sa loob ng unit to do the monitoring of temperature because definitely lulusawin lang siya with our microwave radiation. Okay, so this one, it's a multi-quart fiber component, and our accuracy is also around 0.1. So meaning, this particular temperature sensor here, it will be inserted here inside this flash, and then it will go here into the unit to do the actual monitoring. The benefit of this actually is you have, that's why it's the reason we have a better accuracy of around 0.1. Some other microwave technique is only just using the infrared. So meaning, there's a sensor here, and while this rotates, so ang ginagawa lang po niya ay tinatamaan niya lang po itong part na to, which is indirect. So sometimes the temperature, they can only achieve around 0.5 plus or minus 0.5 degrees with their accuracy. Unlike this one, na totally nakasubmerge mo talaga siya para ma-monitor niya mismo yung actual temperature happening inside the unit. Okay, and what's the benefit of it? Because we all know this is a closed vessel and you are bombarding here at 2,450 megahertz. So isipin nyo na lang po ang 2,450 megahertz per second na radiation, creating a very abrupt change in pressure sa system. And with a very accurate temperature monitoring, it's the only way for them to control the magnetrons. And by the way, the unit that we are handling here is a dual magnetron. Because with the dual magnetron, you have no pulsating effect. So meaning, if you really want a smooth 130 degrees Celsius, it will only place around plus or minus 2 degrees. Given that is a dual magnetron technique. Okay. So inside the chamber here, that is a 10-layer for the Teflon coating, because we'll be working here at the commonly used oxidizing agent, which is the nitric acid. Okay. So this is just to show you, this white plastic here is for the component for our pressure, monitoring the pressure inside the tank. And the little behind is our temperature sensor here, submerged or inserted inside the chamber natin. Okay? So, it automatically stops whenever someone attempts to open the door. And our unit also has a small window here to see what is actually happening during the analysis natin. Okay? And another thing, we're actually capable up to 50 user methods, wherein if you are working at different sample, all you have to do is just type here how many vessels you'll be working and what is your working temp. So this is a very, very nice ways convention for you to know which particular method you'll be running. Okay? And during the analysis, since this is a microprocessor based digestion system, you can also see here the graph showing to you the temperature and pressure monitor, just like an autoclave giving you the pressure at the same time the working temperature inside the chamber. Okay, so that's all on my part. If you have some questions. Sir?
Any question po? Or
Kasi pangitaan ba?
So if you have presentation copies can be ano po, pwede po namin siyang i-send, just send us or an email to us. We are actually we can actually send po yung copy ng aming presentation. Okay? And by the way, we're only not limited into our products now. Should you have your existing or even microwave digestion system, so you can also just send us a message. Send us a message for ano po, assistance. Hello, Ryan?
Yes.
Okay.
Yes po, thank you po sa pag-attend ng aming webinar. So in case you need a copy, you can send email to contact@xperte.com.ph or yung recorded video po nito is i-upload po namin sa YouTube. So pwede niyo pong hanapin XPRT Ventures po doon yung channel namin doon. Salamat po.
Okay, thank you. Thank you so much.